Welcome to the fourth lecture of week 6 on financial mathematics for actuaries. Today in lecture 29 we are going to discuss one very interesting topic and slightly complicated topic, which is varying continuous annuities denoted by I bar A bar. Okay. Let us understand the context for today's discussion. So, here is the findings that we have figured out so far. We have already seen in discrete time steps how this staircase formula works, and that is where we studied these increasing annuities. We have also studied decreasing annuities by looking at descending staircases. We also studied in week 5 how the continuous level annuities work, right. So, where we have constant pressure and flat hose. Now, it is time to go one step further, where the flow is continuous and the pressure also increases continuously, or the pressure is equivalent to rate. Use cases of this is like you are having a startup whose revenue is ramping like from 0 to 1 million smoothly over a period of 5 years, and the payment rate that which you are getting the payments is FT equal to T. Okay. So, this is the problem that we are going to tackle today. The notation that we will use for this is, because we are in the frequency domain we are continuous, in the increase domain we are continuous. So, we will put bars on I and A both. Okay. We have already handled A bar angle N. So, we are already familiar with this. We have used denominator slice machine to derive that formula, right. So, we already know many things about this. We have to just put them in an appropriate framework and use calculus to derive some formulas. So, today's lecture may be slightly challenging. So, let us understand the roadmap and objectives of today's lecture. We want to derive the value of continuous ramp of cash flow. This is the only goal that we have. How will we achieve that? We will first visualize the difference between I bar A bar and I A bar. This is where the flow function is continuous, the flow function is discrete. Okay. Then we will, to derive the formula, we will deploy techniques from calculus. In particular, we will use integration by parts to derive the formula, and then we will, as usual, give you some trap alerts where the bar placements or the how the interest is going to come will determine the denominator delta versus I, and we will also solve hybrid problems which are like increase frequency is discrete and payment is continuous. How will you handle that case? We have already done part of it, but today we will pull all of them together and see the new flavor of these continuous annuities. As usual, our reference mapping is Braverman section 2.3, Chan and Say section 2.6. Okay. Let us begin our journey by visualizing how this thing is happening. So, for example, when you are looking at I bar A bar, you are actually looking at the flow function. What if money flows like water? Okay. So, it is increasing like flowing water. So, its Ft is equal to T, and this is the discrete compounding case where you have money is flowing continuously, but rates increase periodically, right. So, that is our hybrid setup denoted by I A bar. Okay. So, with this we are ready to understand how we will work with this. So, if you look at this left hand side where I have a smooth ramp, if I want to calculate the present value, as discussed earlier, I have to resort to the method of integrals, right. So, at what rate this money is increasing? Ft is equal to T, and I have to bring it to a 0 level. So, I need to consider the discounting factor associated with T. So, T into e raised to minus delta t is the discounting factor that is associated, and whatever period I am doing this leveling for bringing back to present value, I need to integrate over it. So that is what I will do. So it is integral from 0 to n t into e raised to minus delta t dt. Okay. So now how to evaluate this integral? There is a famous formula in calculus, it is called UV rule. So that UV rule says integral of u dv is u into v, that is integral of dv is v, and minus integral of v derivative of u, which is du. Okay. So now I have to identify in this integral what is my u and what is my v, right. So I will identify this particular number as my u and I will identify this particular number as my v. Okay. So I need to consider what is dv for this, that is what is given here. So I will put this entire thing as dv, then the corresponding thing will give me v. Let us do that, and u is equal to t, so du will be du is equal to dt. I have identified this entire block as dv, so I got dv is equal to e raised to minus delta t dt. That means dv by dt is e raised to minus delta t. What will give that? So you integrate it, you will get e raised to minus delta t upon minus delta, that is what my v is. Okay. So now if I know this, I will just feed everything into this formula. So you feed in u into integral dv uv, so it is basically t into what is v, e raised to minus delta t by delta with a negative sign. So that is what I will get here, right, and it is evaluated from 0 to n because it is a definite integral, and then integral over v du. So that will, so this is du is dt, so I will substitute dt here, and v is e raised to minus delta t by delta with a negative sign, so that minus sign is cropped up here. You can easily evaluate this integral, but we do not really need evaluation of this integral, we need to identify the terms appropriately. So the first term is nothing but the boundary term, the second term is integral term. Now relate this integral term with the value of annuity that we were discussing, right. So when we were discussing continuous annuities, which is a bar angle n, we were actually talking about 0 to n e raised to minus delta t dt, right. So this is what we were talking about, and now what is extra here? 1 by delta. So this term is nothing but, this term is actually a bar angle n. Okay. So this is the value of annuity at continuous time. Okay. So then it is multiplied with 1 by delta, and then now you look at this boundary term. This boundary term, if you look at this term which is e raised to minus delta, what is this? This is v, right. So we have v raised to n kind of thing here. So it is v raised to n, then you have n with a negative sign upon delta. So this particular thing is also somewhat we have already seen, and then when I club all these things together, which this is the explanation for that, what I get is the formula which is increasing annuity formula for continuous rates. So I bar a bar angle n is a bar angle n minus nv raised to n upon delta, which is very similar to what we have studied. Okay. So now we have an interesting connection. We have continuous annuities with continuous flow rates, the increase frequency and payment frequency both are continuous. What if we have something called hybrid? So what do I mean by hybrid? If you look at the formulations of these present values, all of them have a angle n minus nv raised to n. Now whether it has double dots or bar depends on the increase frequency, how the increase is happening. if there is the increase in the payment is increase in the frequency is happening at a discrete rate, we have annuity due, correct. If it is happening on a continuous basis, then we have A bar. Now you look at this nv raised to n, that is always going to be constant and it adjusts with whatever frequency you have. Now remember our denominator slice machine that we discussed, where we were replacing I, Im, delta, all those things, right. So that slice machine is still active, and depending on your payment frequency, that slice machine will take appropriate I or delta. So with that understanding, we are ready to have a good beautiful pattern for actuarial math, which is the symmetry of these formulas. So you just have to look at the increase frequency and the payment frequency. If increase frequency is discrete, you have A double dot in the numerator. If increase frequency is continuous, you have A bar in the numerator. If payment frequency is discrete, you have I in the denominator. If payment frequency is continuous, you have delta in the denominator. So with all these things, what you can see is we do not have to really memorize any formulas. It is just A double dot n minus nv raised to n upon an appropriate interest rate, or you can say appropriate annuity minus nv raised to n upon an interest rate. Okay. So that is the basic framework. Now depending on increase frequency and payment frequency, you decide whether it will be I, delta, A double dot or A bar, that is all. So we can now consider this particular setup and answer the question of increasing perpetuities in continuous domain, continuous increasing perpetuity. That means my n goes to infinity. So let us look at this I bar A n formula, I bar A bar n formula, and try to take the limit of as n tending to infinity. Again, what happens to A bar angle n? That will determine the fate. Nv raised to n as usual will converge to 0 because exponential decay will beat the linear growth. So if you look at A bar angle n, we had that perpetuity formula for continuous domain and it reduced to 1 by delta, if I remember correctly. So it reduces to 1 by delta and then we have a simple formula. So A bar angle n reduces to 1 by delta, nv raised to n converges to 0, and therefore the answer for continuous increasing perpetuity is 1 by delta square. That is all. So we have done necessary stuff required for studying continuous annuities. Now let us try to solve one problem. Again, that problem comes from the initial thing, startup ramp. A project generates revenue continuously. The rate at time t is 10,000 times t. This is a linear growth. Duration of the project is 5 years and the force of interest delta is 6%. What do I need to calculate? I need to calculate the present value, right. So 10,000 is a multiplier for ft equal to t. Okay. First identify whether this is a continuous problem or hybrid problem. So if the revenue is generated continuously, that means the flow rate is continuous. Okay. So it is 10,000 t, that is continuous. Force of interest is given, so interest is also continuous. Okay. So one payment frequency and one, we have done that, right, increase frequency, payment frequency and increase frequency both are continuous. So we have a continuous problem. So what is how to approach a solution? Just identify the parameters. First, this 10,000 t, so multiplier of t is 10,000, number of periods is 5, force of interest is 0.06, and then what are the things that you need to calculate? You need to calculate V raised to phi and A bar angle phi. A bar angle phi, because it is a continuous payment. So, we can calculate that V raised to phi is E raised to minus delta raised to phi. So, E raised to minus 0.06 into phi, which is 0.7408. A phi, A bar angle phi will be 1 minus this number upon delta. So, that gives me 4.320. Now, I am ready to calculate the actual thing, which is I bar A bar angle phi, which turns out to be A bar angle n minus n V raised to n upon delta. So, just substitute everything, n is phi substituted and delta is substituted, all those things will give me the final answer of 10.269. Now, I have not yet used the multiplier that is given in the problem. This is the time to use that multiplier, multiply by this factor by 10,000 and you get your final answer, which is 1,02,670. So, now comes your turn. You will try to solve one problem. I have already mentioned hybrid stream, so it is fairly clear, but for yourself judge why it should be a hybrid stream. Annuity pays continuously, so annuity is paying continuously. Year 1 it is 100 per year, year 2 200 per year and so on, year 10 1000 per year. It is an increasing annuity. Delta is 5% and then you have to calculate PV. Okay. First you decide whether this is I bar A bar or I A bar. Pause the video, try to solve the solution, try to solve the problem. On the other side I will solve the problem for you. Okay, welcome back. So, first thing is this is not I bar A bar, because if you look at this particular information that is given to you, it tells you that increase is happening in steps. So, increase frequency is in steps. Okay. So, it is a hybrid problem. So, that rules out this. Okay. So, let us try to solve the problem. Discrete increase in I. So, money flows continuously every year. So, continuous pay is A bar. So, I need to calculate I A bar of 10, correct. So, once we identify this, then we have the formula for that, which is A dot n minus nv raised to n upon delta. The numerator uses A double dot because increases happen at the start of the year, and the denominator uses delta because the payment is continuous. Okay. So, with this setup everything is ready. I have to do the calculation. So, what is the calculation? Delta is 0.05. So, my V will be e raised to minus 0.05. However, I need effective I for A double dot. If I am using A double dot n, I need effective I, but there is one bypass to it. This particular thing can all, because it is A double dot, can be solved by D also, right, and you know D, which is the discounting factor, is equal to discount rate is 1 minus V. So, you can actually exploit this relationship and you can push this into that annuity formula, which is 1 minus V raised to 10 upon 1 minus V. Okay. And this, with this intelligent trick you can solve this problem and you can easily figure out that the numerator is given by 2.003 and the value for which I will divide by this delta is 40.06, and then, so what is the present value? I need to know the multiplier. The multiplier, the payment started with 100 and it was increasing by 100. So, the multiplier was 100 over here, right. So, I will multiply this with 100 into 40.06, that gives me 4006. Okay. So, this actually covers all the topics that are required for module 1. Let us summarize what we have done in this particular class. So, we have actually used the calculus in particular integration by parts engine for continuous varying annuities. We exploited the symmetry in the formulas and we understood that how we will mix and match the denominators and numerators based on increase frequencies and payment frequencies. Okay. Then we also analyzed perpetuities, which turned out to be 1 by delta square for both I bar, A bar, infinity, and you can also study perpetuities for those other problems which are hybrid problems. Okay. And now the next lecture will be, we will consider a theory quiz where we will review the top 10 hardest concepts that we studied from lectures 1 to 29, and after which I will pass the baton to Professor Pramod Naik for financial markets module. Thank you. See you in the next class.